All right, welcome. This is a video on solving exponential equations. So go ahead and pause the video, do the warm-up. All right, let's see how you did. These are your answers. So one's looking for what percentage of the initial population, so you just need to find out what e to the negative 0.46 times 4 is. And then there's the solving for number 2, and number 3 is writing an equation, putting in your calculator. All right, so before we start, we have to remember these exponent properties. They are very, very important. Where did that random horizontal line come from? I don't know. Okay, so we need to know these. These are Algebra 1 exponent properties that you learned in Algebra 1. So here they are. So a to the first power is the same thing as a. Like, okay, that's an easy one. If you have a negative exponent, we cannot leave negative exponents in our answers. So if we have an answer that's leaving something such as that, we know that you can, if the exponent's negative, drop it like it's hot, meaning bring the base and the exponent to the denominator, put 1 over it, and then make the exponent positive. So a to the negative m is the same thing as 1 over a to the m. Likewise, if you have a negative exponent in the denominator, so if you have 1 over a to the negative mw whatever, you can bring it to the top. So that's a to the w. Anything to the 0 power is 1. If you have the same base, so a times a, and they have the same base there, then and they have exponents on them, you can keep the base and add the exponents. So a to the m times a to the n is a to the m plus n. If you have a power to a power, so if you have a to the m to the nth power, you keep the base and multiply the exponents. So that's a to the m times n. And then lastly, if you have the same base and you're dividing with exponents, that have exponents, I should say. For example, if you have a to the m over a to the n, you can simplify it by keeping the base and subtracting your exponents. Or you can look where there's more, keep those, and then subtract one from the other, dependent on what you have to do with the problem. Okay, so let's go ahead and use these properties to solve this equation. Okay, so we're gonna do lots of solving. This is all no calculator until we get to 2 that I think get to use your calculator, and you'll see why. Okay, so here we have 3 to the 5x equals 27 to the 2x minus 3. So what we're looking for is to get the same base. Okay, we're looking for to get the same base. So we have a base of 3 and a base of 27. So the question is can they be rewritten as the same base? And they can. 3 is 3 to the first power, and 27 is 3 to the third power. So we're going to leave 3 to the first power alone. We're going to put 3 to the 5x. We don't have to put 3 to the first power. It's already 3 to the first power. And then 27, we're going to rewrite as 3 cubed. Okay, and then that's the 2x minus 4, right? So now we have that property that's the power to the power, right? So that property says that you can keep your base and multiply your exponents. So that becomes 6x minus 12. And then this is 3 to the 5x. So now you have the same base, so you can keep the base, or sorry, we already have the same base. So now, in order for this to be true, these would have to be equal. If those two are equal to each other, right, then those two exponents have to be equal to each other. So to solve for x, we're gonna do 5x is equal to 6x minus 12. Subtract 6x from both sides. We get negative 1x is equal to negative 12. Doesn't look like an equal sign. So x is 12. Okay, we do not have to check our answers on exponential functions due to the fact that exponential functions could look like this, let's say, or like this. That's exponential growth. This is exponential decay right here. If you look at their domain, it's all real numbers. That means all x values work. So any x value that we get that is a real number works. Okay. Looking at the next one, if we look at our bases are 1/2 and 2. Both 1/2 and 2 can be rewritten as a base of 2. The right-hand side is 2 to the first power, which is what we already have. So 2 to the x plus 3. We don't have to change it to 2 to the first power. It is 2 to the first power. And then 1/2 we can change to, remember we can use that property that says that 1 over 2 is the same thing as 2 to the negative first power, right? So we're going to change that to 2 to the negative first power, and then to the x power. Power to a power, keep your base, multiply your exponents. And now, since our bases are equal, we can set our exponents equal to each other. So we're going to do negative x is equal to x plus 3. Subtract x from both sides. We have negative 2 is equal to 3. Negative 2x is equal to 3. And then divide both sides by negative 2. So we have x is equal to negative 3 over 2, or negative 3 halves. I'm turn the sound off my computer, so here we go. Okay, next one. Let me box my answer. There we go. Next one. Same idea, right? That's what this whole lesson is, right? So 2 and 16, if you look at those two, we can rewrite them to have the same base. This is 2 to the first power, so we're just going to leave it. And then 16 is 2 to the fourth power, right? And then that's x minus 5. So power to a power, keep your base, multiply your exponents. So that's 2 to the 4x minus 20. And now you can set your exponents equal to each other. So we have x plus 1 is equal to 4x minus 20. Subtract x from both sides. Add 20 to both sides. We have 21 is equal to 3x, so x is equal to 7. Next one here, both can be rewritten as a base of 3. This is already written as a base of 3. This is 3 cubed. X minus 2 is equal to 3, so x is 5. So some of them are nice, super easy, right? We'll get to more challenging ones momentarily. All right, here's the next one right here. I pretend I don't notice that calculator, right? But I have base of 3, base of 7. 3 and 7 cannot be rewritten as the same base, right? If it was a 3 and an 8, sure. If it was a 3 and a 27, sure, but not a 3 and a 7. So notice that this has a little calculator next to it. We're going to have to use a calculator to solve this. We could use logarithms, but that's the next chapter, I believe. So we instead are going to use our calculator. So what we're going to do with our calculator, we're just going to use the graphing function. We're going to go to y equals, and in y equals, we're going to put the left-hand side of the equation. And then in y equals 2, we're going to put the right-hand side of the equation. And then we're going to see where they intersect. The x value at which they intersect is the solution to this, right? You can do this with any equation on the face of the earth, right? So keep that in mind when you're taking your ACT and you're allowed to use Desmos. All right, so I'm going to pull up my calculator here. Let me undo that. Let me close that out real quick. I wonder if I just click on it. No. Okay, sorry. I thought it was going to show up little on the side of my paper, so my bad. Okay. All right, so let's move this over so it's not taking some life is good right now. I'm happy. I'm healthy. I'm not going to get upset. Okay, woosah. All right, so my calculator is set to factory settings right now. So I'm going to go y equals, and then in y1, I have 3 to the x power, and then in y2, I'm doing 7. My calculator, as you saw in the beginning, was reset to factory settings when I turned it on here. So if you hit graph right now and you graph something that wasn't on the negative 10 to 10, negative 10 to 10 coordinate plane, you might not see it. So to fix that, you could always hit zoom 6, which is zoom standard, and it'll graph it negative 10 to 10, negative 10 to 10. So there's y equals 3 to the x. There's y equals 7. And then I can see that they intersect right there. So now I want to find that intersection. So remember, to find intersections, you're hitting second trace, which is calculate. Option number 5 is intersection. And the trick here is that if you see the intersection on the paper and you just hit enter 3 times, it will find it. How it does that is it's asking you right now, is it on the first curve? If you look in the upper left-hand corner, it is on the first curve. It's on y equals 3 to the x, so hit enter. Then it asks you, am I on the second curve, which is really a line. Y2, it is, if you look at the upper left-hand corner, it's on y2 is equals 7. So yes, it is. And then it's saying, should I guess the intersection of these two? Yeah, that's why I came to you. Hit enter, and then it tells you the x value which they intersect. So we are going to round to 3 decimal places because there are no directions, and that's what we do when we have no directions. Okay? All right, now also if you wanted to, you could check your answer because it's saying 3 to this power is 7. So this is a rounded answer, so it's not going to be perfect, but we can check to see if it's, somewhat close. And I can actually memorize the rest of these digits. 2, 4, 3, 7. All right, 2437. 2437. 3 to the 2437. I have short-term memory loss. 2437. 2437. So if I check this, it's going to be close to 7 because it's right here. It's either truncated or rounded. And you can see that it's very close. So it is, in fact, correct. All right, let's go do the other one. Same idea. In Y1, we could put the left-hand side in Y1, but what I first should see is that this base isn't isolated. I can't get 2 and 18 to have the same base, but there's that 3 in front, so I should divide both sides by 3 to see if something better happens. So we have 2 to the 4x plus 3 is equal to, come on, 6? No. I cannot rewrite 6 as a base of 2. Some people will say, yes, 2 times 3. That's not an exponential function with a base of 2. That's multiplication. I would be, if it was 2 to the 3rd power, which is 8, or 2 to the 4th power, which is 16, so not a 6. So I'm going to do the same thing I did in the last one. In Y1, I'm going to put 2 to the 4x plus 3. And in Y2, you can put 6. So Y1, I'm going to hit clear because writing over things is never a good idea. 2 to the 4x plus 3. And then in Y2, I'm going to hit clear and put 6. And this is actually easier to do in your graphing calculator, entering those equations, because your Desmos doesn't like entering this. It's like annoyed by it. Okay, so they do intersect. I'm going to hit second trace, option number 5, enter, enter, enter. And it'll tell me my intersection. The x value is negative 0.104. Voila. Okay. All right, let's move on. Get out of here, calculator. Let's go back to ones that are not calculator because that's the more important one. Anyone can use a calculator, but not everyone knows how to solve these. Okay, look at your bases. 8 and 2. Yes, we can do that. That's 2 to the 3rd power. And then leave this as base 2. And then I have power to a power. So that's 3x minus 3. And here, this is 2 to the x plus 2. I get 3x minus 3 is equal to x plus 2. Subtract x from both sides, that's 2x. Add 3 to both sides, that's 5. Divide by 2, and I get x is equal to 5/2. Okay, go ahead and pause the video and try the next one on your own. All right, let's see how you did. Both base of 12, 12 squared to the 2x plus 1. This is 12 to the 5x minus 1. So we get 4x plus 2 is equal to 5x minus 1. So subtract 4x from both sides, that's x. Add 1 to both sides, that's 3. X equals 3. All right, go ahead and pause the video and try these two. All right, let's see how you did. 2 to the n plus 1. And then this is 2 to the 4th power, the n plus 7. Power to a power, keep your base, multiply your exponents. 4m plus 28. 2 to the n plus 1. Set your exponents equal to each other. M plus 1 is equal to 4m plus 28. Subtract m from both sides, that's 3m. Subtract 28 from both sides, that's negative 27. Divide by 3, m equals negative 9. Okay, moving on to the next one. All right, here we have 1/3 and 3. We can rewrite 1/3 as 3 to the negative 1st power. 3 we'll keep as a base of 3. Multiply your x, or sorry, here we go. 3 to the power to a power, multiply your exponents, that's negative x minus 2. And then set your exponents equal to each other. Negative x minus 2 is equal to x minus 1. Add x to both sides. Add 1 to both sides. I have negative 1 is equal to 2x, and then divide both sides by 2. X equals negative 1/2. Careful with your algebra here. I stumbled on that one for a second, but just be careful with your algebra. Okay, go ahead and pause the video and try those two. Let's see how you did. 8 is 2 cubed. 16 is 2 to the 4th. power to a power, power to a power, keep your base, multiply your exponents. Keep your base, multiply your exponents, 12x plus 16. Set your exponents equal to each other now that the bases are the same. Subtract 12x from both sides, divide by 3, get x equals 16/3. Okay, next one. 2/3 is your base, 8/27 is your base. So I can rewrite, if we separate numerators and denominators here, the numerator is a base of 2, the numerator is a base of 8. I can rewrite 8 as 2 cubed. Numerator is a base of 3, denominator is a base of 3, denominator is a base of 27. I can rewrite 27 as 3 cubed. So I can rewrite this as 2/3 cubed. So we have 2/3 to the 5x plus 1 is equal to 2/3 cubed to the 4 minus x. So now we can say this is 2/3 to the 5x plus 1. And then this one, keep your base, multiply your exponents. 12 minus 3x. Set your exponents equal to each other now that you have the same base. 5x plus 1 is equal to 12 minus 3x. Add 3x to both sides, that's 8x. Subtract 1 from both sides, that's 11. Divide by 8, you get 11/8. Marvelous. Okay, so now what we're going to do is we're going to move on to ones that are slightly more complicated, okay? So these ones are using more properties, right? You have to think harder about them because they just are slightly more complicated, okay? A little bit more challenging, I should say. All right, so this one right here, on the right-hand side, I have 3 to the x times 5 to the x. So what I can do with that is, maybe I don't know. So I'm like, I don't know. On the right-hand side, I have 225. I know I can rewrite 225 as 15 squared, all right? So I look at the left-hand side, and I said, can I get that to be a base of 15? And I can. It is using, I'm going to go zoop, 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 zoop. This property backwards, all right? I'm using this, no, it wasn't that property, my bad. It was this property right here. I'm using this property, not that property. Hold on, what was it again? It was 3 to the x times 5 to the x. Oh, that's power to a power. Yes, I'm using that backwards, okay? So I'm using it backwards, and I can split it so that it's in here, 3 times 5 to the x, right? I mean, it's already split, right? This is using power to a power on all of it, okay? So this is not even, the property's not even up here. So I don't know why I came up to this. I should have made a better plan, right? Let me go back to our problem. The property's not even there. But it says, what it's saying is that, let me add this property here. If you had, let's make one up here, 2x to the 3rd, y to the 4th squared, right? That's this times itself. So in other words, you can bring this exponent to each of those terms. So this becomes 2 squared times x to the 6th power, because you're using power to a power there, times y to the 8th power there, okay? So it's reversing that property. So this is 3 times 2, this is 4 times 2, they all have a 2, so you can bring them all together and bring it to the 2nd power. I think that was an over-explanation that might have confused people more, so let's just go ahead and do the problem. I can rewrite this as 3 times 5 to the x power, because if you look, that property that I just showed you said you can bring each of those products to that power. Now I can change 3 times 5 to 15. Okay, I think I might have complicated more than that than I needed to. And while I'm here on this one, I might as well do power to a power here. So power to a power, multiply your exponents, that's 8x minus 14. Okay, so if you ever have the same exponent, you can use that same property. You can keep the exponent, and if this is being multiplied, you can multiply the bases and keep your exponent. There you go. That's a better way of saying it instead of being super complicated. All right, now you can set your exponents equal to each other. X equals 8x minus 14. Subtract 8x from both sides, you have negative 7x equals negative 14. Divide by negative 7, x equals 2. Voila. If you wanted to mental math check just to think that I'm not cuckoo, you could. Plugging in a 2 here, you get 9. Plugging in a 2 here, you get 25. If you multiply those two, you get 220. Hey now, you get 225. And then if you plug in a 2 here, you get 8 minus 7 is 1. And then that's right. Yeah? So like, all of our properties we did worked out beautifully. All right, let's move on to the next one here. All right, so here on the left-hand side, I see a base of 7. On the right-hand side, I see a base of 1. So at first, I'm like, but I'm going to work through this one. So I have 7, and then I have a power to a power, so I'm going to multiply my exponents. 2x squared minus 3x. And I can rewrite 1 as a base of 7. I can rewrite 1 as a base of anything I want, right? Because I know anything to the 0 power is 1. So I'm going to rewrite that as 7 to the 0 power. So whenever you see it equal to 1, don't be like, oh, I can't rewrite that as the same base. Yes, you can write any base to the 0 power is 1. All right, now, simple here. Set those equal to each other. 2x squared minus 3x equals 0. This is a quadratic, so the first thing I ask myself is, can I solve it by square rooting? The answer is no. So then I want to try to factor it. First thing I look for is a GCF. There is a GCF. So then I can set each factor equal to 0 and solve. I get x equals 0, and x equals add 3 divided by 2, 3 halves. Okay, moving on to the next one. All right, looking at this, I have a decimal, and I'm like, well, but decimals can be written as a fraction. So say out loud what that decimal is. That is 1/100th. So write it as that. 1/100th to the x power. All right. And then this side, same base, keep your base, 10, subtract your exponents. So I have 3x minus 5 minus x minus 1. All right, so now if you look at your bases, both 100 and 10 can be rewritten as a base of 10. So this is 1 over 10 squared, so the x is equal to 10. And then let's clean this up. Subtract each of those. So 3x minus x is 2x. Negative 5 minus a negative 1, or negative 5 plus 1 is negative 4. Okay, if you want to distribute the negative, you can. So you can say like that's a plus, that's a minus, that's a plus. You can do that too. Okay, so on the left-hand side now, I know that if I have, I know that if it was 1/10, I can rewrite it as 10 to the negative first. So if it's 1 over 10 squared, I can rewrite that as 10 to the negative second power. Right? Like, yes. And this is 2x minus 4. And then this is 10 power to a power, multiply your exponents. And then now I can set my exponents equal to each other. 2x is equal to 2x minus 4. Subtract 2x from both sides. Negative 4x is equal to negative 4, and x is equal to 1. How lovely. What a beautiful answer for such a complicated looking problem. All right, the very last one, and then you can try some practice on your own. So don't look at this at first as two separate equations. Look at just this one right here, okay? So just look at the top one. So this has a base of 5, and this has a base of 1/5. I can rewrite 1/5 as a base of 5, right? So I'm going to do 5 to the 2x minus y is equal to 5 to the negative first. So now for that, I can set my exponents equal to each other, right? So I have 2x minus y is equal to negative 1. Now, if you notice, this equation has an x and a y. So I cannot solve it unless I have another equation, right? I need to make a system, but lo and behold, I do. So this one is a base of 2, and this one is a base of 32. I can rewrite 32 as a base of 2. It's 2 to the 5th power. So this is 2 to the 4x minus y is equal to 2 to the 5th power. And then I can set those equal to each other. Exponents, that is. 4x minus y is equal to 5. And now I just need to solve this system. Move it over here because there's more room. All right, I'm going to use elimination. I'm going to get y's to cancel out. One of them is negative 1. The other one's negative 1 also. So I'm going to multiply the first one by negative 1. And and it becomes negative 2x plus y is equal to positive 1, and now I can combine those. So that's 2x, the y's cancel, the y and negative y cancel, equals 6, x equals 3. And then now I just need to solve for y. So you can plug it back into either one. I'll plug it back into the first one. 2 times 3 minus y is equal to negative 1. 6 minus y is equal to negative 1. Subtract 6 from both sides. Negative y equals negative 7. Divide by negative 1, y equals 7. So my ordered pair solution of where these two intersect is 3 comma 7. Oh my gosh, that's my birthday. What a coincidence. I swear I made up this problem. Okay, go ahead and practice on your own now with the MML, and we'll do some more practice in the next lesson.